Hiya! So in this video, we're going to look at a couple examples on applying one forms to different vector fields. So what we're going to start off with is with the first example, where first we needed one form, right? We're applying one form to vector field, so we needed one form. So the one form we're going to work with is the one we've been using a couple times, x dx plus y dy. And we're going to look at the vector field w equal to minus y ex plus x e y. So this one, if you remember, is a not conservative vector field. So this was the omega tilde that we had seen a few videos back. And so what do we have here? So here, remember, we want the g's and the h's. So what is our things here? So this is our g's, g1, g2. So here we have g1, g2. Okay. And then for w, this is going to give us the h1. So h1 and h2. So here we have h1 and h2. Now, if we recall here, when we sum these up, this just gives us 0. So it might seem anticlimactic, like, oh, this is just always going to give us 0. It doesn't matter what point we give. But this is precisely what we were talking about in one of the previous videos, where everything is orthogonal to one another. So like when we compare these, everything was kind of orthogonal. And so this is kind of giving us the basically stating that this function doesn't really change on this vector space. It stays exactly where it is. Okay, so we'll look at this later, that there's nice geometry. But let's look at what happens when omega is exact. Because this is going to be, this gives us some nice things as well. So if omega is exact, well, our g's are basically given by these components, right? So g1, and this is our gn. And here, if you look at this formula, this should be recognizable. So this is what we had seen, I think the second video or the third video, dw of f. And we can kind of go all the way back and look at this. Where was it? This should be here, right? So here we have this precise formula, right? So this we've already seen. In other words, this df of minus w, so this was our omega, right? Because, oops, what is happening? Nope, stop. This is our omega, since it's exact. In other words, in exactness, these two things are the same. So the directional derivative of f along the vector field w is precisely these points. So in some sense, these one forms are generalizations of directional derivatives. So let's look at an example, because that's just a lot of randomness. So here, let's look at 2.29. So we're going to look at the same stuff from this example, so omega and w, but this time we're gonna recall that omega is exact. So here, remember that omega is exact. So recall this is exact. In other words, we have the function f is equal to x squared plus y squared over 2. This is the function that omega uses in order to get that it's exact, right? So here, let's look at these two again. So here we've redrawn the two images from before, so we can kind of look at them one after another. And this is kind of one of the things that we were saying, that I was implying from before. If you kind of look at this, since omega is exact, the geometric intuition is that this function here is going to give us the directional derivative of f along w. Now, since the point that moving a point moving around the vector field w traces out a circle, right? So if we look at a point here and we kind of follow the vector space, this is going to give us, in essence, a circle. A little hard to try this, but in essence, it's a circle. The value of this function f doesn't actually change as we go around the circle. So f stays the same as we follow the directional derivatives. In other words, you can kind of think of this as these lines, right? So this is precisely the what's it called? The level sets. And so in particular, what this is saying, the directional derivative of f along w is just 0. So it lines up precisely with our value of omega blank w. So this is in essence the general idea and the philosophy behind this. And we will end this video here. We will also end this week here as well. Enjoy your next 6 weeks with David. Hopefully it's even more fun than when you had with me. It was a pleasure. And I will see some of you around for the tutorials. And yeah, have fun. I'll see you in the review sessions at least, so it won't be the last. But yeah, all right, peace.